We think that expanding our knowledge in scripting makes us a better scripter at the end, but is that really true? I claim that there is one important aspect to scripting no YouTuber has talked about yet. If you want to know more about it, then check out my second channel, link is in the description. Alright guys, so welcome to today's tutorial video right here, and in today's tutorial video, you know what this is about. So this is about the mastery system, of course, and I'm gonna explain everything regarding this mastery system giveaway from the last video, alright? And it has been 2 days now, okay, so I didn't upload 2 days, although the next video was actually pretty clear. And, well, yeah, it wasn't really that clear to me because, as you guys know, I'm currently in a bit of a struggle regarding this channel right here, because I don't really, or let's say the feedback I received doesn't really meet my expectations of the channel, but yeah, this is how it is. So I think that I finally after these 2 days now, finally found peace with the situation, okay? So yeah, that's just to that. Now, let's actually take a look into this. So as you guys know, or as you guys have probably seen, this sword right here, this sword system is our Katana system, our Katana giveaway system. I've just changed it a little, so I've modified it. I've converted it into a tool, as you can see. So we have a tool, and once you equip it, this equip animation plays, this GUI appears, and once you click this tool right here, you of course start attacking, okay? So that's to that. Now let's actually take a look inside of this tool. So what happens is that we have this tool, okay? And this tool has a bunch of events, such as the equipped event and the unequipped event and the activated event. So right here. And what basically happens is that we have just changed apply Katana, which was, you know, which fires server right away once the script has loaded, and now is bound to this situation of this event of equipping the tool. So once you equip the tool, you basically fire server this apply Katana thing right here. Now, same goes for remove Katana. I think that remove Katana wasn't even a thing in that giveaway video we had back then. So I have edited this remove Katana fire server, I think. So the video is already 3 days old. I've already forgot a lot of it. So a lot of stuff I have done in that. But assume that I have created that within this mastery system thing right here. And then we have attack Katana, which is bound to this activated event. And this activated event basically happens when you have this tool equipped and perform a left mouse button click. Now, when you recreate all of these, it is important that when you create a tool that requires handlers false, and I highly advise you to set can be dropped to false as well. Okay, so untick both of these boxes and then you're good to go. So let's actually start from scratch, so from up to all the way to the bottom. So what happens right here is that we are defining a bunch of variables. First one is our local player, so that's clear. Second one is the character, that's clear as well. And the third one is this remote event. Okay, so it's Katana remote. So this is nothing new to you. So we have already seen that in that Katana system video. The fourth one is a bit interesting. So sword mastery module. We will get back to this soon. So this is obviously module script, which is inside of the replicated storage. So remote parent. Wait for chart, sword mastery module, as you can see, and then we have to require this one because this is the module script. All right. The last one is equipped, so there's some kind of debounce. It is actually a variable which just tells you whether tool is equipped or not right now. All right. Yeah, I'm still fighting the consequences of my illness. So I was ill a few weeks ago, and I'm still having consequence of that. Yeah, so script parent equipped. So when this tool has been equipped, what happens is that we set this variable to true. We fire server this apply Katana thing. I'm not gonna go into this one because you guys already know about it. So when you have seen the Katana system video, if not, then check it out. Next thing is that we refer to, or we create a variable called GUI, and we refer to this mastery GUI right here. So we have a screen GUI called mastery GUI inside of our player GUI, aka starter GUI right here. And when we take a look into this one, we see that, now let's actually play and let's actually analyze it while having it equipped, while being inside of this testing mode right here. So player GUI, mastery GUI, there we go. So as you can see, we have we have this frame right here called background. Okay, so this one is basically the background of all of these. Then we have a UI gradient. Okay, then we have a bar, basically our mastery bar right here. So 10 out of 22, as you can see, is the current progress of our mastery. And when we open up this one, then we have a local script, which is responsible to update the bar and this mastery text right here. But we will get to this soon. Then we have a bunch of effects, so effect 1, effect 1. I was too lazy to rename those, but those are basically those small lines right here. So I wanted it to look like the bar in Blox Fruits a little. And then we have this thing called inner bar, which is this orange bar right here, and this describes the progress, okay, the progress of your current mastery EXP right here. When we open up this one, then we have another frame called shade, and this shade right here is this, you know, this transparent white shade. And then we have a thing called progress text, so basically this 10 out of 22, so this text right here. Okay, now we have another frame, so scrolling frame right here. This one holds all of the skills later on, as you can see. It is important that this one has a UI list layout, otherwise your frames right here will not be automatically laid out for you, so you have to do it yourself then. Okay, then we have this thing called skill 1, and this one is invisible by default. And this one is basically, let me show you what it is. So basically this script, so this Katana Script right here. So once you equip this tool, what it does is that it brings this GUI right here up, and then it clones this skill, puts it inside of here, makes it visible, and then it changes all of the text labels right here according to the information delivered by the module script. Okay, but we'll get back, we will get to that soon, so don't worry about that. But yeah, this is just a template for all of the previous frames. I've just deleted just to demonstrate you this. Okay, and this frame title right here is basically just this text, so Sword Mastery 2. Okay, so that's how our Mastery GUI is composed. Now let's actually stop playing. Let's take a deeper look inside of the script. So, this GUI, okay, make sure that this background frame is visible, because it is invisible by default. And then we have a tween, and what this tween does is that it just brings this background frame, so it is currently somewhere down here, it brings it up. That's literally what happens inside of this tween. So I'm not going to explain this tween service in depth, but just know that this is the overall purpose of this tween. Now we have a for I loop, for IV in pairs loop, and yeah, so let's look inside of this module script right here, because that's important now. So this module script right here, as you can see, is required right here, so we are using it. And now we are looping through a table called info, which is inside of this module script. Okay, and this is our table. Now this table contains all of the info, all of the information, regarding the moves. So basic slash is our first move, as you can see. So it is very, very important that your table follows this scheme right here, and especially this one, because this one is essential when you want your skills to have a certain order. Okay, so first move, second move, third move, fourth move, fifth move. Okay, that's the order you're going to have inside of that frame. So basic slash is going to be on top, because basic slash requires mastery 2 only. The second one requires mastery 8. Okay, that's the reason why we have ordered things out. So it wouldn't make any sense to have this right here, so there's a Shura move as the first move, then this one as the second, and then this one as, now let's say this one as the third, this one as the fourth, you know. So you hopefully get what I'm trying to express right here. So this one follows a certain idea of having the lowest mastery required all the way to the highest mastery required. Okay, that's basically how this is composed. Now we have this, which is important to describe the order, and then we have this table, okay, which contains a bunch of other entries right here. So the first one is called name, and this one is basically your move's name. So in this case, I've just created random ass moves, so basic slash, okay, just random ass sword moves. Now the key, it is important that you type this out in enum format, so enum.keycode and then q E, or whatsoever. So depending on what kind of key you want this move to have. And then the third one is called mastery required, and this one describes or displays the mastery, the mastery which is basically required in order to unlock this move. In this case, mastery 2 is required. Now, when we take a look at all of the other moves, you can see that the scheme is always the same. So name, key, and mastery required. The only thing which changes are the values. So 8, 14, 20, or E, R, T, or the name right here, okay? So that's how this table works. Now, we are basically now looping through this table. And what happens is that for each entry right here, so 1, 2, 3, 4, 5, we are cloning one skill frame right here. Okay, so one skill frame represents one entry, aka one move. That's basically what happens. And now we are changing all of the frames parts right here. So this text label, this text label, this text label, according to the information delivered in here. So frame info.parent. So wait, we are basically cloning this frame. That's the first thing. Now we are parenting this table, this frame into this scrolling frame. And now we are referring to this mastery requirement text. We are changing the text to mastery. So basically this string, and then those two dots connect this string with this string, as you can see. And what this string is that, so V is basically this table right here. So this is V and this is I, okay? V, I, V, I, V, okay? So everything after this equals is V, everything before is I. Just for you to know about that. Now, when I refer to v.mastery required, I basically refer to this. Okay, that's what happens. So basically, mastery dot then everything right here. So 2, 8, 14, 20, or 40, depending on which entry you currently are at. So basically any number. Let's pick 2 for example. So 2. Problem is that 2 is a number and not a string, so we cannot connect a string with a number. That's the reason why we're using toString, which converts anything not non-string to a string. In this case, a number into a string. So basically 2 as a string, mastery string, and then we connect both strings to 1, and then we connect this string by having these two dots right here to this string, which basically just displays required. That's how it works, okay? Now, skill name text. So that's the next thing, the next text label, and we equal this with v.name. So basically this one, or this one, or this one, depending on what your entry is, as you guys know. Now, skill key text. So the same game as up here, we have a string. So this bracket right here. Then we have two dots, which connect this string with this one, and this in this case is a string, because v key would be this enum thing right here, which is not really a string, but putting a name in front of it basically converts it into a string for us. So instead of having enum.key called q, you basically just have q. So bracket q bracket. That's how it's expressed later on. And then at the end, we make sure that the frame is visible. And that's all. That's everything which happens right here. There is nothing too complicated whatsoever. So that's everything. So when you equip the tool, everything which happens is that. Now, when you unequip it, as you can see, the variable is then set to false. Then we fire so with this remove katana thing. Let me actually just quickly go through its remove katana, because I have edited. Yeah, that's something I have newly added to this katana system. So when you fire so with remove katana, then we fire all clients with remove katana and basically the performer. So the performer of this move right here, move called remove katana. So we can consider this as a move at this point. And the move is basically to remove the katana. Right? Then when we take a look inside of katana replication, so remove katana right here, what happens is that we wait 0.5 seconds. This has to do with the unequipping itself, because when we do not add a wait at that point, there is a higher chance of animations glitching whatsoever, okay? That's the reason why you should add a wait. Minimum 0.5 seconds. 0.5 up to 1. Depends on your mechanics, depends on your game, but yeah, you just have to find out for yourself. Now, right here, we are basically checking if this performer has an instance inside of its character called Katana. Okay, at this point, it has to be our Katana, because that's basically what happens up here. So we clone this Katana from the replicated storage, and then we put it inside of our performer's character. Okay, now we are basically checking if it is still inside of there. And if that's the case, then we destroy it, and then we have another for IV and pairs loop. And this one loops through all of the playing animation tracks of our performer. So basically, we are able to access all of the playing animations of our performer. So all of the animations which our performer currently performs. So idling animation, attacks, swords, whatsoever. And in this case, we want to check if there is an animation called Katana Idle Walk. That's basically the animation we have played up here for applying the katana. And if we have found it, then we want to stop it. And that's it. That's how it works, okay? So just to quickly get through this. So now this is basically done. Can I forget about it? Yeah. So when we unequip this tool, what happens is that we once again have this variable, similar as up here, and then we have a tween. And this tween, for this time, moves the GUI from here down to here, so back to its origin. And once this tween is completed, we make sure that the background is not visible. Okay, so this might be unnecessary at this point because you're basically moving the GUI down there, and of course it is invisible to you. Okay, so there is no need to set this property to false. But I'm someone who really likes having things organized and structured, and if I have decided to make it visible up here, then I need to make it invisible down there. So that's just my personality at that point. But this step is actually unnecessary at this point. So you can really get rid of that, and you can also get rid of this one if you want to. Basically unnecessary, but yeah, depends on you. Now, right here. So after this frame has disappeared, what happens is that we are having another for IV and pairs loop, but this time we are looping through the scrolling frame. So remember, once we have equipped this tool, we are cloning a skill frame for each skill which can be unlocked, okay? And down here, this is the part where we clean those frames up. So after we have unequipped, we are looping through that scrolling frame which holds all of the skill frames, and we are basically checking if the instance inside of the scrolling frame is a frame. Okay, so we have to check that because there is, for example, this UI list layout which is not a frame. Okay, and we do not want to delete this one. So if our instance is a frame, then we want to destroy it. Okay, that's how we clear up the scrolling frame. Now, right here, we have another important part. This part right here is responsible for you being able to basically equip this, and then while having it equipped, being able to perform all of these moves right here. So Q, E, R, T, Y. Okay, and this happens via user input service. So you guys probably know about this. So what the user input service does is that it is responsible to detect your user's input. That's obvious, I think. And we have this event called input begin. And this event happens when you have started with an input, okay? Started. It doesn't determine whether you have ended or not. It only determines, or it only fires when you have started an event, okay? Now, when you start with an input, I'm sorry, not with an event, with an input. So when you start with an input, you receive the input which was done, okay? That's obvious. So have you pressed the key? Have you pressed the button? Okay, so all of that information is gathered inside of this input variable. The second one is called GPE, so an acronym of game processed event. This one basically tells you whether this input was done on purpose or not. So was the player interacting with in-game elements such as a shop, such as a chat, whatsoever? or not, okay? And we basically want to check if this input was done on purpose. So that's the reason why we have to exclude GP. So if not GP, so if not game processed event, then we know that the user wasn't interacting with anything and has done that input on purpose. And then we are basically looping through this info table once again, and then we are checking if input, so if our input equals our key. So our key right here, now wait, so inside of this info table. So we have keys right here, which belong to one certain move, and we are checking if our input was one of these keys, and whether the tool is equipped. And if that is the case, then we fire server this remote event with the task do move and then the name of the move. Okay, and that's everything regarding this local script. So this part right here, I've already talked about this, but basically when you activate the tool, so when you perform left mouse button click, we fire server as attack katana. Okay, and this basically leads to the slashing of the katana. Now let's take a look inside of katana server. So we have katana server and data store left, and yeah, those are basically the parts where things get a little bit complicated, but it's still understandable in my opinion. So we have a bunch of if statements right here, okay? So what we have to focus on is this one. The rest is unnecessary, more or less, except for this part. So this part is still important, okay? But we will get to this soon. So if the task is to do move, then we still have to verify that the player is capable of doing this move. So what does it mean to be capable of doing a certain move? So as you guys know, we have requirements right here. So mastery 2, mastery 8, whatsoever. And we have to know, first of all, is the player, or has the player enough mastery level to perform this move? Secondly, even if this sounds weird, but does this move even exist? Okay? Because in an era of ROBLOX exploiting, it is very easy for ROBLOX exploiters to just fire server any random ass remote event, filling in any random ass arguments, just trying out a bunch of things without getting banned whatsoever. And that's the reason why it's important to always check the arguments you receive. So if argument 1, basically the name of the attack this player wanted to perform is an actual attack, that's basically what we are checking right here for. So if argument 1, so the name of the attack the player wanted to do, is actually one of these. If that statement is true, then as you can see, player data, we are creating a variable called player data. Now we are doing this. And this is where things get a little bit complicated. So I have to explain you the data store first of all, so that you guys can understand this part. So let's take a look inside of the data store, and this is the next big thing we have to talk about. And after this, we're pretty much over. Although we still got some stuff to do. But yeah. So we have a bunch of variables up here. The first one is the data store, of course. So game get service, data store service, and get data store. And then just any random ass name you want your data store to have. Keep in mind, changing the data store's name will lead to data loss, data reset whatsoever. Just keep that in mind. Now, the second variable is called remote. So basically, data remote. So we have a single remote event for this data and a single remote event for the katana. Keep that in mind as well. The last variable is called data folder. And this folder is going to store every player's data inside of here. So every player who's currently on the server, so every player's data. Okay? And this one, default data, is a template for, default data. So basically a data template. We have three entries, 3 stats, call whatever you want it to. But this is our data we are currently capable of having. So the first one, sword mastery. Basically, your sword's mastery. So you start at 1 by default. The second one is Sword Mastery EXP. So basically, the EXP you currently have, which is at 0 by default. The third one is Sword Mastery EXP needed. So the amount of EXP which is needed in order to increase your mastery, which is at 10 by default. Okay? So that's also our default data. Now, what happens is that once a player joins the game, so game players player edit, connect function, we receive the player who has just joined, alright? And the next step is then to load all of that data. So when you work with data stores, and especially when you are at the part where you load the data, it's highly recommended to use this thing called pcall, because when you work with all of that data load code whatsoever, when it comes to loading the data, those parts are very vulnerable to encounter random ass errors, alright? And to prevent your data source script from breaking just because of any random ass error, I recommend you to wrap everything, so everything of this loading process, inside of a pcall. So how this works is that you have two variables right here, so success and error m, aka error message, equals pcall. Now we have this code we want to run wrapped inside of this pcall. Now if this code for some reason throws out an error, it doesn't break the whole script. It is isolated, okay? So it stays isolated, and when it throws out an error, you can basically check. So if error m means if error message, then you can even print out this error message, or you can even check whether this thing was successful. So if success, then print loaded data, for example. So you could do that, but I'm not gonna do that because, well, I don't want to. Okay, now how do we even load this data? So we have this variable called loaded data, alright? And we are this variable, and we are referring to data store get async. So we are referring to our data store, and we are using this get async function. What this get async function does is that it needs some kind of key. Okay, so you have to imagine the data stores like this. So you have a key, and under this key you have data assigned to. Okay, let's say your key is 1, and you want to assign your personal information to this key 1. So you can only access the data of your personal information by having the key, which is 1. Now we have, so you will see this later on in the save function right here. When we set the async, means when we save in this data store, we assign our data, which is our data folder's data, to our player user ID. And that's the way in how we receive what we have saved onto our user ID. So how we receive our data, which we have just saved, by using our user ID, which was the key before. Okay, so get async and then the key, which is our user ID. Then we receive all of the data which was assigned, which was saved with this user ID key. And if there is no data, so if we haven't saved anything yet on this user ID, then we want to make sure that we create an entry inside of this data folder right here. So this data folder, as you guys know, and we create another entry, a new entry with our player's name, and we set this equal with our default data, so the data everyone has at the beginning. Now, if we have data, then we still create a new entry with our player's name, and we equal this with the loaded data. And that's how the loading process works. Now, we have two cases right here, or basically two events. So, game players, player removing. Basically, when a player leaves the game, we receive the player who's leaving. Now, this is a little bit important to understand. So, my problem with player removing is that it didn't work for me back then while I was testing. It used to work for me in real games. So when you like go to the ROBLOX webpage and then play your game from there, then it does work, but it doesn't work while testing it out in studio. That's at least my experience with that. That's the reason why I check every time whether the session is not in studio. And if that is the case, then we want to use player removing as an event to save the player's data. Okay? And I also have bind to close right here. And this bind to close, so this happens when a game is close to shut down. And I use bind to close when I'm testing out in studio. So that's the reason why we are checking whether the current session is in studio. All right. So when the session is in studio, then we use this as an event to save. When the session is not in studio, then we use this event to save. Now, how this works is that it basically loops through all of the players and then just applies the save function to them. So how does the save function work? I've already quickly explained it. So instead of doing get async, we now do set async. And we need the key. We want to save this data on. So the key is our user ID right here. And the data is basically, so we are referring to this data folder and then to our entry, to our player's entry. So player.name. And everything which is contained inside of that entry is basically our data. And then we save this onto this user ID. So I hope that this was clear. Now, that's how this data store works. Now, you guys might argue, all right, so the way on how you've explained things makes it seem, or yeah, just makes it seem that this data store is isolated. So it is a system in itself. So you cannot really gain influence from the outside. So it doesn't really communicate with the outside. So how does that work? So how can this data store now be used? So how can you like get your data, change your data, whatsoever? So to do that, we have two ways. We have a remote event and we have a bindable function, which I've called change value, because this bindable function only fulfilled one purpose at the beginning, and that was to change the value. But now it actually fulfills two purposes, but we will get to this soon. So the bindable function and the remote event. Now the remote event is responsible to communicate to a client, okay? And the bindable function is responsible to communicate between another script, so another Soa script. Now let me explain this. So let's start with the remote event first. So when this remote event is fire served, then you can basically do two things. You can either tell the data store to save someone's data or to retrieve someone's data, but you cannot change the data from a remote event. That does not work. You can only change your data from or by using the bindable function, but we will get to this soon. So when you fire serve this remote event with the task to save, then it saves, all right? If you fire serve the remote event with the task retrieve, then we fire client, the player who has fire served, with the task give data, and with this this entry inside of that data folder. Okay, and we will take a look at an example of this soon. Now, let's take a look at this bindable function. So how does this work? So script change value. So this one dot on invoke. So you basically have to invoke this bindable function. So invoking is basically just another term for, I don't know, fire serving. So you can imagine invoking a bindable function is the same as fire serving, or just, just fire serving a remote event. Well, that might be a bad example at that point, but you guys hopefully understand what I'm trying to say. So it is just some kind of activation process which activates the functionality of this. Okay, so when we invoke this thing, we have to input some arguments. First of all, the task. Okay, so what is this thing supposed to do? And then we can throw in a bunch of arguments. So argument 1, argument 2, argument 3. Now, we can only have two tasks at this point. The first one is to change, and the second one is to get. Now, let's take a look at change. If what is change, then we have a function called change value. Let's actually take a look into this one, because this one is interesting. So, function change value. What does this thing require? So it requires the player you want to change the value of, and the value you want to change, so the value's name, and the value you want to change the value with. Okay? So basically the value you want to override the former value with. So the first step is to see if this value even exists. So if data folder and then the player's name. So we are going inside of the player's entry, and then value name. Okay, so does this value exist? If this is the case, then we are changing this value with the value which we are supposed to change it with. And then after that, we perform another function called check mastery. Now let's take a look inside of this one. So function check mastery, this only requires the player at this point. So what happens is that we have another if statement, and this if statement checks if the player's sword mastery exp is either greater or equals our sword mastery exp needed. And if that is the case, then we revert the sword mastery exp to 0. We increase the sword mastery exp needed by taking the current amount of sword mastery exp needed, and adding some random 10 adding a random 10 or 30 to it. So basically, let's say that you have a sword mastery exp needed of 10, and then you fulfill that, and then you gain something around 10 and 30 on top of it. So either 20 to 40, so something in between that. So that is random, all right? And then we also increase the sword mastery. So sword mastery equals the current amount of sword mastery plus 1. And then we fire client to the player with the task give data, and then, you know, the current data right here of our player. That is important because we have to keep the player updated on any data change. And this is basically what has happened right here. So we have changed the whole mastery right here of this player, and we have to update the player with all of the new values. All right, and that's the same as right here. So once we have changed something right here, we have to inform the player, we have to update the player. That's the reason why we perform this give data right here. All right, so that's all to change value. The second thing is get. So if the task is to get, then we return the data folder of, so argument name is basically our player's name. So we return the player's data right here. And that's all what happens. Now, let's take a look inside of here back again. So we have left off right here. So script parent data store change value invoke. So that's the example I was talking about. So we are invoking the Spinal Function right here with the task get and with the player. So we are basically receiving the player's data. And yeah, we can now refer to this player's data by writing down player data and then just easily name of what we are trying to refer to. So if the player's data sword mastery is greater or equals the mastery which is required right here. Remember, we wanted to check whether the player is even capable of doing that, performing that attack. And if that is the case, then yeah, then you have to do this for yourself. So I don't know what kind of moves you're having, or I don't know how your system even looks like. So this is just a blueprint for you to know that after this, you have to write down your own code. So I don't know what you're doing. Either you're fire clienting back to replicate all of the attacks, or you're doing something else, I don't know. But you have to do it right here for yourself. Alright, so that's it with this part. Now you guys might ask, alright, so how are we even able to increase our mastery at this point? So you can increase your mastery by killing an enemy. So Ray instance parent humanoid die to connect. So basically when the enemy dies, then we are first of all checking if the humanoid has an instance called dead inside of it. If that is the case, then we return. And if that is not the case, then it just goes on right here. Okay, and by goes on, I mean it is going to create an int value inside of the humanoid called dead. So this one functions as some kind of cooldown, alright? So that you guys know, so that this part right here, where the EXP is increased, doesn't fire multiple times. That's the reason why we have to add this cooldown. Okay, so we are doing the same as right here. So player data, we are getting the player's data, and then we are invoking this change value right here with the task change, and we want to change the player's sword mastery EXP by the current amount of EXP plus, and then math random 1 to 4. So the current amount of EXP plus any random number from 1 to 4. That's what happens right here. Okay, so the player's mastery EXP is increased once dummy right here dies. Now, the last thing I wanted to show you is located right here. Okay, that's the last part, then we are hopefully done. So this local script is responsible to update the bar. So how does this function? So we need exp needed, and mastery level. Those are the three things we need. Okay. And how do we receive this? So wait, yeah, coroutine resume, coroutine create. So what is this? This thing, this construction makes this part run apart from the rest. All right. And I'm thinking why I've done it this way. Is it actually unnecessary? We don't have to wrap this inside of a coroutine. Yeah, forget about the coroutine. Remote on client event connect function what and argument 1. So this is basically a part where when we do this, for example, so file client give data, so you guys have seen this. So this lands here at the end. So at this on client event, all right? And if what equals give data, so if that is a task, then we receive the data. So arg1 is then our data, and then we can just easily do arg1 sword mastery exp, you know, so on, as you can see. Now we can update the bar by, you know, giving it everything it needs. So the exp needed, and the mastery level, as you guys can see right here. That's what we are doing. And before we start off with this, I still would like to show you what this does. So 2 seconds after the script was loaded, we fire the data remote event with the task to retrieve. So what this does is that once you're trying to retrieve, it basically sends back all of the data. Okay, so you can imagine this as some kind of request to get the data. Then you get it right here. All right, so how does this work now? So we are creating a variable for the upper bar, which is basically this inner bar right here. Then the progress text, which is this 10 out of 22, and the mastery title, which basically says sword mastery colon 2. Okay, and those are the 3 instances we are upgrading. So we are changing the mastery title to sword mastery, and then those 2 dots, and then the same way as before by inputting a number, so the mastery level, and converting it into a string. Now the progress text follows the, or almost follows the same scheme. So the exp, and then connecting this exp text to this text, this string, which is a slash, and then the amount of exp needed. All right. The last part right here is a tween, which tweens the upper bar size, so this inner bar size. And how this works is that you have to imagine we are currently at 0.5, all right? So it is currently at the half of its full size, okay? So currently at 50%, so it fills up 50% of the whole bar. That's what 0.5 expresses. Now, when you divide the exp with the amount of exp needed, you will receive the percentage you currently have of the XP needed, okay? And that is basically a number in between 0 and 1. So let me just give you an example: 0.2, 0.3, 0.4, 0.5, okay? And those are numbers which perfectly fit into this scheme, so into 0.5, you know, so they perfectly fit inside of here. And that's the reason why we can use this to, you know, determine the size on the x-axis. I hope that this was understandable. All right. So let me give you an example. Let's say we have an EXP needed of 10, and we currently have an EXP of 2. So 2 divided by 10 is 0.2. Now 0.2 size on the x-axis is basically 20%. So it fills up 20% of the bar. Now let's say our EXP increases to 9. So 9 divided by 10 is 0.9. Basically 90% of the bar is then filled up. Now when we reach 10 out of 10, so 10 EXP, then 10 divided by 10 is 1. And we fill up 1 means 100% of the bar. And you have to imagine it like that, alright? That's how it works. So that's it with the video, guys. So that's all I had to explain. As you can see, 10 out of 22 is almost at 50%, but not really. Is a little bit lower, and now we have increased it. And yeah, that's how it works, guys. So that being said, thanks for watching, guys. Leave a like, subscribe, share this video to all your friends, and feedback in the comment section, guys. Take care and see you in the next video. Yeah.